So, shifting from the structural challenges that we have within the US water system and the exceptional drought conditions that we're facing across the Republic, let's look at some of the exciting solution that comes from combining agrivoltaic systems with precision irrigation and some of the positive impacts it can have on the water, soil, and ag systems, as well as improving solar system performance. So, just to review, agrivoltaics has numerous benefits for water and soil. And some of that comes through the direct shading that when we put the solar array above, it creates that microclimate and that it takes a lot of the direct sun off of the plants and also helps protect the soil from direct sun. And then because of the microclimate, as the plants transpire and release water, a lot of that stays contained within the microclimate. And at the University of Oregon, at their Rabbit Hills agrivoltaic solar array, they've seen significant productivity gains of up to 90% in their agricultural operation. And interestingly, they found that semi-arid pastures with wet winters may be ideal candidates for agrivoltaic systems. So again, really highlighting the application in the Western United States, the Southwest, and into the middle part of the Republic are really exciting areas for the application, translating what's been happening in Oregon and Arizona. And taking a little deeper look at what they found at the University of Arizona, which has one of the longest standing agrivoltaic projects in the US, they find that the impacts were really three factors. And the one, that there were cooler air temperatures, the direct sunlight and the shade that it created, and then the much lower demand for water. And they found that many of our crops do better in shade panels because they're spared from the direct sun. And to summarize some of the really interesting results, in crop production, they found that Chilean fruit production was 3 times greater in the agrivoltaic system. And then water improvements, some of them are really staggering in a desert environment. Increased water efficiency of 328% among the plants and grasses, decreased transpiration of up to 65% less, increased soil moisture of 15%, and as a result, peppers needed 50% less water and tomatoes 30% less water. And from one of the studies here, they have this really great quote: not only does this simple concept increase crop yield while using less water, it also improves solar efficiency. Sounds like magic, but it's ecology. So zooming on this 15% increased soil moisture, wanted to pull some data from MCAT, the ATRA Sustainable Agricultural website, as well as the USDA Economic Research, and look at the 5 principles of healthy soil. First, protect the soil surface, often called soil armor, minimize soil disturbance, increase plant diversity, having live plants and roots in the soil continuously, and the integration of livestock. So as we put agrivoltaics with precision irrigation, with regenerative agriculture, both grazing and crops, we can see this nexus of benefits that really improves the soil health and helps maintain water. And from the USDA, healthy soil has amazing water retention capacity. For every 1% increase in organic matter, meaning more healthy soil, there's an additional 25,000 gallons of water per acre that are stored. So looking at agrivoltaic systems and precision irrigation, I want to define what precision irrigation is. Precision irrigation is a more sustainable agricultural approach that allows for the water and nutrients to be delivered to the plant at the right time, the right place, in a small measured dose to create optimal growing conditions, and simultaneously also really solves that structural problem where we have a lot of inefficiencies in our current irrigation system. So it's worth noting that irrigation systems are a major farm and ranch expense. Irrigation systems have a high initial capital and labor cost for installation, high ongoing maintenance and repair expense. They're very labor intensive, whether you're moving pipe through a field or using a lot of power to move big things like pivot lines. And the frequency of how well they're managed dramatically impacts their crop performance. So if you don't move the pipe one day, the plants don't get watered. If someone doesn't run the pivot lines, no water gets to the crops. And there's a really great scenario here from the aces.edu in Alabama that really goes into detail on some of the major costs of the 3 irrigation types. So as we look at combining precision irrigation agrivoltaics into a joint power and hydro grid, we're going to start looking at a real example here. So in this example, we're doing an integrated dual axis tracking with a bifacial solar fence system. And because we have this superstructure of the fence and the solar, it allows us to then integrate precision irrigation on top of that superstructure versus having some huge pivot line or needing to manually move pipes through the field. And that creates a lot of benefits on how we can more precisely deliver water to the pasture, but it also has solar system improvements. Because you've integrated the ag irrigation system with the solar system, we're now cleaning and cooling the plantals more often. And then want to highlight bifacial solar fencing. Bifacial solar fencing is one of the most transformational applications of agrivoltaics. We have an entire section on butterflypower.org and a deep dive video into all of the vast reaching positive impacts of solar fencing. But just to summarize here, when we create a bifacial solar fence, we create a hyper strong guaranteed superstructure, meaning the galvanized steel, if that's utilized, and the solar panels are guaranteed for 25 years. But we also get this very strong superstructure to integrate the precision irrigation. But we can also put in power generation, power distribution, and lighting systems, and then integrate the solar panel cleaning system with the irrigation. So it all happens in a multi-system integration. And just like permaculture, it gives us a foundation to really stack functions. And then in a really magical aspect, one of the major risks for all projects, but specifically in the Western United States, is fire. And so as we integrate precision irrigation, we then have built-in fire protection for both the ag operation, but also for the solar system. So let's look at solar system performance and how this integration with precision irrigation can really improve the power performance. And this is a US company called RST Clean Tech Solutions. And they have a really great video here to summarize the impacts of how we can really improve solar panel cleaning.
Solar panels are making the world a better place. But over time, solar panels get dirty, resulting in less energy production. This soiling hurts investment returns and increases your electricity bills. So, what can you do to keep your solar panels performing optimally? Keep your panels clean all the time. RST CleanTech has developed a fully automated cleaning system that cleans your panels every week, virtually eliminating soiling losses. This can increase energy production by up to 30%. The RST system is the first solution to economically address panel soiling and maximize power production. Current cleaning methods present several problems. Cleaning is done periodically, meaning your solar panels will get dirty again. Paying for only a few weeks of extra production is not cost-effective. Cleaning panels on a hot day with cold water can cause the glass to crack. And if soft water is not used, limescale buildup can destroy the panel. In addition to this, these methods use chemical solvents, high pressure, and abrasive materials, all things that over time will wear on the panels and can void the warranty. With the RST cleaning system, you don't have to worry about any of these things. The system will make you money by minimizing soiling losses, and it will also preserve your panel warranty. Our patented system purifies the water from limescale. The water is then applied at low pressure at night when the temperatures are cooler. Soiling on the panels won't build up because they are cleaned every week. And that's why we don't need high pressure, chemicals, or abrasives to keep your panels clean. RST system is based on drip irrigation technology and has been field tested since 2011 on millions of panels. The simple and ingenious design is suitable for almost all solar arrays, from residential rooftops to utility scale tracking systems. The system is easy to use through our RST CleanTech app, allowing you to remotely control your cleaning and notifying you of faults. With RST, you will enjoy effortless cleaning with up to 30% more energy production, putting money back in your pocket where it belongs. The RST technology is now widely accepted around the world.
So, really highlighting here that by more frequently cleaning the solar panels, RST claims you can get 30% more power production if you clean your panels once a week. And now apply that in the same way they've applied drip technology to the very labor-intensive process of cleaning solar panels. To every time we're irrigating the field, we can also clean the solar panels, and all of the excess water that comes off of cleaning the solar array goes into irrigate the pasture. So again, to highlight, solar panel cleaning is a high ongoing expense, labor and equipment intensive, and the frequency dramatically impacts the system performance. And here's a video just showing whether you're doing it manually or you're going through and using heavy equipment. This is a very intense operation. And then also another huge component of solar system performance is vegetation management. And whether you're doing it with machines or we even now have robots, it's a high ongoing expense, which is labor or equipment intensive, and the frequency of management dramatically impacts system performance. And when we integrate a regenerative grazing operation with an agrivoltaic system, the critters will take care of all the vegetation management. So let's try and sum this up into how it can really improve the economic performance of a system. And here we have an example from NREL on a 10 megawatt single axis ground mount tracking system in Colorado. So this is a fairly large system, but what we want to pull from this pro forma is that the opportunity to really improve the economic performance through a reduction in OPEX expenses. So this system costs $25 million to install, and its total operation expenses are $221,000 annually, and over 25 years is a net present value that's $2 million in total OPEX. But we've highlighted here three different categories, which are cleaning and vegetation management. And the annual expense of that is $41,000 versus the $221,000 of annual expense. And over 25 years, those two categories represent $450,000. So by integrating precision irrigation to really reduce down the solar panel cleaning, which also dramatically increases the power production and how much revenue the system can produce, and then by introducing regenerative grazing into the agrivoltaic system, we can bring down the vegetation management and really take what is a very competitive field of solar system cost that's, increasingly based on thinner margins, and take one of the largest categories of ongoing expense and turn it into a positive column. Thank you for taking the time to view this section of the United States Agrivoltaic Energy Storage and EV Microgrid Market Intelligence Analysis. Really deeply hope that you've found this really valuable and hopefully inspiring. And if you're not watching the entire section on butterflypower.org, really encourage you to come and see all sections to get the totality of this amazing opportunity. And regardless of what channel you're finding this transmission, would be deeply appreciated if you give it some love, give it a like, and share it with a farmer or a rancher or anyone who's interested in participating in the regenerative transformation of our economy, our energy sector, and our environment. Any investors who are looking at an amazing opportunity to transform their capital into the regenerative future. And it's just a deep honor and blessing to be here in this time and to participate in this great work. And we are the butterfly generation. It's time to rise and shine. Time to transform and fly.